I've got some features to share with you today in Desmos that a lot of people don't know about for graphing parametric functions. And then I'm going to show you an amazing application, both in 2D and in 3D. Let's go ahead and dive in. We want to start off with this line, and it's given to us as a parametric function to find x equals and y equals. Desmos does not work that way. Instead, Desmos is going to take that and graph it as an ordered pair. So in an empty cell, graphing that as an ordered pair, I'm going to put the x coordinate in first as its definition, 1 plus 2t, and then comma, the y part of that definition, which is 2 plus 3t. Now it's giving me parameters going from just 0 to 1 for t, and I certainly want to increase that. So let's increase that to say maybe -10 to a 10. So I've got more of this line, but I'm missing one super important feature of a parametric function, and that's the direction. The direction of this graph depends on t, and we can see the direction by duplicating our graph and tracing it. Here's how we're going to do that. I'm going to click on settings, and then I want to duplicate the parametric function that I've got here. Let's hit done. I'm going to change the original to be a dotted line, and to do that I just click and hold on the circle. I'm going to change it to be a dotted line, and I want that to be black. And for the second one, I want it to be just a little bit thicker. So I'm going to click and hold on this one, and let's just change this to a thickness of 4. Now the most important part is to change the parameters on that second line. That's going to be my tracing line. And I'm going to change that to an n for the upper parameter. I do want to add a slider, and to match the parameters, I'm going to change n to go from, just clicking on n equals 1, to go from -10 to 10. So let's back up the slider to the very beginning, and then hit the play button, and I can see that it's graphing as it is increasing. That gives me the ability to draw arrows on my line as well to designate that direction. Next, let's graph a circle. So I'm going to get rid of all of these, and the circle that I want to graph is also a parametric function, but I'm going to graph that in terms of the coordinates. So we're going to go cosine t and sine t. Now again, it just gives me a tiny little piece of that. Let me zoom in so we get a better view. I'm also going to change these parameters, and to get a circle I need to do a full rotation from 0 to, let me click on that upper parameter, and I'm going to change that to 2 pi to get our 2 pi. Let's do the same thing that we did with the last example so we can trace it. So settings, I'm going to duplicate that, done. Change the first one to be dotted and black, and then change the second one to be a little bit thicker. I want a brighter color as well. And then we're going to add that slider by changing the upper parameter to n, add that slider, change the limits to go from 0 to 2 pi 2 pi, and I want that to be a 0. Let's drag that slider back to the beginning so we can see our starting place and the direction as we hit our play button. I want to take this circle and I want to extend it into a helix in 3D. I'm going to copy this function, and I'm just going to do a Control-C, and then I'm going to open up my Desmos 3D graphing. You can get there either from the Desmos homepage or desmos.com/3D. I've got mine opened here. I'm going to go ahead and paste my function by doing a Control-V or a Command-V. Again, it gives me those parameters, but I want 0 to 2 pi to get the entire circle. If I click, hold, and drag to get a better view of this, I can see that I do have that circle in the XY plane. But I want to change this into a helix. So I'm drawing that circle as t is increasing. I'm going to go up to my function, and then I'm going to add a comma t. That gives me at least a partial helix. Let's go ahead and divide t by, I don't know, let's divide it by 4 to get a better look here. And I also want to extend these parameters. Let's go from -4 pi to 4 pi. To get that all-important direction, I'm going to go ahead and duplicate the curve. So I'm going to duplicate this and then hit done. As I click and hold on that original function, it doesn't give me the option to do dotted lines. So instead, I'm just going to put that one in gray, and then I'm going to let the other one be my tracing function. Let's make that just a little bit thicker. I'm going to go a 2 there. And then I'm going to change this upper parameter to be an n, and I do want a slider there for n. Let's change the parameters there on n. Clicking back to get that slider, I'm going to drag it all the way back and then hit play so we can see that it starts at the beginning and we've got the direction in which that increases. We're going to look at Lissajous figures next, and they're an amazing application that connects sounds, specifically musical chords, with these parametric curves. I'm going to open up this really great simulator that I found, so kudos to the creators. You'll find the link down in my description. As I play and combine these tones, I end up with these Lissajous curves, which we can recreate using parametric functions in Desmos. Let's go ahead and go back over to Desmos in 2D now. I'm going to delete these, and let's go ahead and put up our first Lissajous curve. So I'm going to put this in parentheses, and these are combined sine waves or sound waves. I'm going to do sine of 5t slash 4, closing that parentheses, and then the second sine wave is going to be the sine of, we're going to do 3t slash 2. And I've got this, but again, just partially graphed. Let me go to my default view and get the entire graph in here. I want to graph this from -4 pi, so 4pi to 4 pi. And if I zoom in, we'll get a much better look. And that was the Lissajous curve that we saw as we combined those tones. I can also get this to graph in 3D. Let's go ahead and grab this and then copy it, and then over into 3D. I'm going to paste this, and again, I want this from -4 pi to 4 pi. And as I look at the curve there in my XY plane, I can see that this matches what we had in 2D. Let's go ahead and put a third sine wave though here, and I'm just going to keep that third sine wave really simple and do the sine of t. Now as I take a look at this, I can see that in the XY plane, I still have that same function, but I also have some elevation to this. Let me zoom in a little bit more so you can see that, and I can also spin this so you can see exactly what's happened. We can also, of course, trace this curve. Let's move our slider all the way back to -4 pi. I'm also going to slow the animation down a little bit to 0.75, and let's just play through that once so you can see both the starting point and the direction. Subscribe for more videos like this one. Desmos does so much more. Check out this next.